Hi, welcome to our new unit, which is going to be dealing with radicals. And the lesson that we're going to be dealing with is simplifying radicals. So the objective is, how do we simplify radical expressions using the product property of square roots? Okay, so the product property of square roots is basically the product of the square root that can be written as a product of a square root of each factor. So we have square root of a times b, which is equal to square root of a, and then with your symbol for multiplication, times b. So you can split whatever is underneath the radical. If it's multiplied to each other, you can split it into its extended form. For the first example, we see that square root of 20 is equal to the square root of 4 times square root of 5. Because when you multiply 4 and 5, you would get 20 underneath the radical. So if the radical factors can be written independently, then the radicals can be simplified independently. So then, notice how from square root of 20, you break it down to factors of 20. One of them is going to give you a perfect square of 2, and the other one is just a prime number, and it stays underneath the radical because it cannot be broken further down. That will give you composite numbers. So it's just 1 and 5, so it stays underneath the radical. So we're going to be learning how to simplify radicals in this format where we have a big number underneath the radical and then split it into two factors. One of them that will give us a perfect square, and one of them will be a prime number. Okay, so other terminology that you need to know: radicand. Radicand is a number under the radical sign. The radical, in its simplest form, if it contains no perfect square other than 1. So that's what the radical is. The number underneath the radical, which is the radicand, is basically a number that has no perfect square. So it's a prime number. So to simplify radicals, the first thing you do is factor out the perfect squares, because we want to pull them out and it will be outside the radical, and then we're left with the prime number. So take the square root of the perfect square factors, and then represent the simplified radical expression as the product of a whole number and a non-perfect square radical. This may sound like a mouthful, but when we do the problems, you'll understand understand the connection of what the steps are and the problem itself. Right, so before doing any problems dealing with simplifying radicals, we need to know the square root of certain numbers. So we have all of these square roots. They're going to give us a perfect square. So we have the square root of 64, square root of 9, square root of 49. We know that it's going to be 8, that was going to be 3, and the other one's going to be 7. Square root of 4 is 2, square root of 1 is 1, and the square root of 0 is just 0. And the square root of 25 is 5, 36 is 6, and 144 is 12. So these are numbers that you should know, because basically if you work backwards and you multiply these numbers twice, you would get the number that's underneath the radical. So 8 times 8 is 64, 12 times 12 is 144, and the opposite of in order to get from 144 to 12, you do the opposite, which is square root. So again, that's another thing that you need to know. The opposite of squaring a number is doing the square root, not dividing. It's because dividing is attached to multiplication. It's the opposite. But the opposite of squaring is the square root, and if you're doing the square root of something, the opposite of square rooting is squaring it. Okay, so when it comes to estimation, figuring out if you don't have like a perfect square, you're not going to get a perfect square, then you can estimate. I mean, yes, you can use a calculator, but let's say you didn't have a calculator. You can find the two square roots that will give you a perfect square that will fall on either side of the square root number that you're looking for. So for example, we have square root of 80. So what two numbers underneath the radical that will give you a perfect square will be before square root of 80 and after square root of 80? So we know that square root of 64 and square root of 81 falls, square root of 80 will fall between square root of 64 and square root of 81. So you know square root of 64 is 8. You know that the square root of 81 is 9. So 80 is close to 81, so we would say like 8.8, 8.9. So it's approximately 8.9. Same thing with square root of 27. It falls between the square root of 121 and 144. So that will give you 11, and that will give you 12. And since 127 is closer to 121, so let's say 11.1 or 2 in that case. Same thing with 148. It falls between 144. It falls between 140, 169. Got 12 for 144, 13 for 169. 148 is close to 144, so we would say 12.2. So the same thing with the other numbers. We got the square root of 200, closer to 160, 196, which gives you 14, and the other one is 15, so it'd be 14.1. And 34 between square root of 25 and 36. This gives you 5. This gives you 6. And you would say 34 is closer to 36, so 5.8 approximation. And then with 97, square root of 97 is between 81 and square root of 100. This one gives you 9. This one gives you 10. 97 is close to 100, so it'd be approximately 9.8. So again, that's one way of working it if you didn't have a calculator, to get the approximation of whatever that square root number is. So radicals, unless they are perfect squares, are irrational numbers. So you may have learned in middle school about rational, irrational numbers, natural, whole numbers, integers, all that stuff. So any number underneath the radical that does not give you a perfect square is irrational, because you're dealing with decimals that just goes on and on and on. There's no repetition, and there's no stopping point, so it just keeps on going. Irrational. So if the non-perfect squares are exact answers written in simplified, the non-perfect squares are exact answers written in simplified radical form, not decimals. So notice how I gave you an approximation of the decimals. We're not going to do that. We're going to have the simplified radical form. So we're going to see examples of that. All right. Let's go on to our first example. So they want us to simplify the following radical expressions. So the first one, what is the square root of 72? Yeah, you can plug it into your calculator and get an approximation, but we're not looking for that. We're looking for is the simplest radical form. So the first thing you're going to do is you're going to find the factors of 72. So find the factors of 72. Once you get to that, the second step is you're going to look for the greatest factor that will give you a perfect square. So notice that, yeah, 4 can give you a perfect square of 2, 9 can give you of 3, but 36 can give you 6, and that is the biggest one of the biggest factors of 72. So we're going to choose 36, and then whatever factor is attached to it, which is 2, is what we're going to choose. Then we're going to choose, like I said, we choose 36 and its other factor 2, and then simplify. So notice how I have 72 as underneath the radical, and then I do that tree. Remember when you did factorization, factorization, trying to find the prime factors? In this case, we're looking to simplify the radical. So we chose 36 because it's going to give us a perfect square of 6, and then radical 2, 2 is just a prime number, so it's not going to be broken down, so it stays underneath the radical. So then we have our answer as 6 radical 2. So that is the simplified radical form of radical 72. And notice that I didn't use a decimal, because majority of the times you will see the answers in its simplest radical form. So get into the habit of doing that, because if you do have a decimal and they're not asking you to give a decimal, you can get points off for that, or they won't accept the answer. It would just want it in its simplest radical form. So be careful. All right, let's look at the second example and the third example. So we need to find the square root of 90. So the first thing we need to do is find the factors of 90. So they're all written down there. And now you need to find which greater factor will give us a perfect square. So we see 9. 9 will give us 3. What is 9 attached to as a factor? 10, because 9 times 10 gives you 90. So now you're going to break it down to square root of 9, square root of 10. Square root of 9 will give you 3, and then 10, even though it's a composite number, it can be broken down to 2 and 5, but 2 and 5 cannot be broken down any further, so you can't do anything with it. So we just leave it as square root of 10. So it will be 3 square root of 10. That is the simplified radical form for square root of 90. Let's do 27. The factors of 27. 9 will be the biggest one. That will give us a perfect square. So then we use 3 and 9 underneath the radical. Square root of 9 will give you 3, and 3 radical 3. Square root of 3 will just stay under like as it is. And it will be 3 radical 3. Okay, so the question is, what happens if there's a number before the radical? So we got two examples showing that. I've highlighted the 3 in blue and then the 6 in green. So let's do example 4. So when you have a number in front of the radical, that number will be carried down all the way till the very end. So the first thing you're going to do is deal with what's underneath the radical. So let's look at 75. We find the factors of 75, and we notice that the only factor that will give us a perfect square is 25. So 25 is attached to 3 to give you 75 when you multiply. So then you'll break down the radical 75. See how the 3 is brought down? So the square root of 25, square root of 3, and then since square root of 25 gives you a perfect square of 5, the radical 3 will stay underneath. You bring it down, and notice that I'm taking the 3 times 5 because I pulled out the 5 from underneath the radical because it was simplified. I'm going to multiply the 3. Whatever number was outside the radical will be multiplied to the number that you pull out when you find the perfect square. So 3 times 5 gives you 15, and you keep the radical 3 underneath the radical, and you got 15 radical 3. Let's go for the next one. We got 6. That 6 is going to be carried on until the very end. So let's deal with 27 underneath the radical. 27 is factors. Got 127, 3 and 9. 9 will give you a perfect square. What's attached to it is 3. That's the other factor. So we're going to break square root of 27 using those two factors. So square root of 9 times square root of 3, and then 6 gets carried down. Square root of 9 gives you 3. That 3 is pulled out, and it's going to be multiplied by the 6, and that will give you 18, and the 3 underneath the radical just stays there because it can't be broken down, will stay underneath. So you get 18 radical 3. So anytime you have a number outside the radical, deal with the number underneath the radical first, break it down, and then whatever becomes a perfect square will be multiplied to that number outside. And then whatever is underneath the radical stays underneath the radical. Okay, let's look at another example. It's taking a while. Okay, so now this is a situation where you have two radicals being multiplied. All you have to do is multiply the numbers underneath the radical. Multiply them, but make sure you keep that radical sign. So for this one, radical 3 times radical 8 is radical 24, a square root of 24. Notice I usually say radical. It's the same thing. You can say square root of 24, or you can say radical 24. That's the name of the symbol, the radical symbol. So now you do the same thing. 24, you break it down to its factors. Find the one that has the number, one of the factors that will give you a perfect square. 4. So then 4 with 6. So you're going to break 24 into square root of 4 and square root of 6. Square root of 4 gives you 2. Square root of 6, even though it's a composite number, can be broken into 2 and 3, but you can't go any further. So you just leave 6 underneath the radical. And then we get 2 radical 6. Same thing with example 7. 5 times 6 underneath radical is radical 30. Find the factors of 30. Okay, so notice how we can't find a factor that will give us a perfect square. All right, so then what do? Just leave it as is, square root of 30. Just like when we did with the 6, yes, 30 can be broken down into composite numbers because it's a composite number, but we can't find one that's going to give us a perfect square, so we can break it down further and simplify it further. so we just leave it as 30 underneath the radical. So when you do a lot of these problems, you'll know which one to leave underneath the radical and what can be broken down further. So 6 is one of those examples that just stays underneath the radical as is. Same thing with 30. All right, next one. All right, so we're going to do a word problem that deals with radicals. So it says, Lindsay makes a square garden with an area of 75 square feet. Find the length of each side in simplest radical form. So that means I don't want to see any decimals. All right, so we know the area of the square is 75 square feet. So you know area. So what is the area of a square? So that will equal side square. So you know the area is 75. So we plug in A, 75 for A, and then we set it equal to side square. So notice how I put the square root on top of each of them, because the opposite of squaring, because since we want to have s by itself, there's a square there. The opposite of squaring is doing the square root, not dividing by 2. I've seen that many times, and it is wrong. Don't get the math cop after you for doing an illegal math thing. So the opposite of squaring is doing the square root. So once you do that, then you're going to find the square root of 75. Same thing, you find the factors of 75. Oh, I just put a little run. Opposite of square is square root. So you find the factors of 75. You notice that 25 will give you a perfect square, and what's attached to it is 3. So then you're going to break down 75 to square root of 25 and square root of, oops, that's supposed to be 3. So let me change that. So that way we don't have that error. Oops. Okay, eraser. And change that. And then, so that should be 3. And then the next thing, you know that 25 gives you a perfect square of 5. And then that should be 3. So made a mistake with that. I know it was 3, but I must have written too fast and not realizing it. Alright, so let me change that to 3. And there you go. So it's 5 square root of 3, and that is the side for the square. Alright. So let's see. I think we've reached the end. Alright, so going back to the beginning, if we can get there. Alright, so we learned about simplifying radicals. We learned that basically if you have a number underneath the radical, it can be broken down to its factors. One of them will give you a perfect square, and the other one will be a prime number that stays underneath the radical. So, and you also learned that the opposite of squaring is doing the square root, not dividing by 2. All right, and then when it comes to finding, if you don't get a perfect square and it's going to be a number that's not perfect, then you have to simplify it in its most simplest radical form, no decimals. So we've seen examples where first thing, find the factors of the number underneath the radical, find one that will give you the perfect square, and then use the factor that is attached to it, break it down, and then the one that gives you the perfect square will come out from underneath the radical, and then whatever's underneath the radical will stay underneath. You also learned when there's a number outside the radical, that number is going to be carried down to the very end because it will be multiplied to the perfect square and then get your final answer. So if you have, for example, 25 gave you 5 as a perfect square, multiply 3, and then it gives you 15, and then the number underneath the radical stays there, and you get your simplified radical form. And also, if you have two numbers underneath the radical, multiply them. And then, same thing, find the factors, find the one that gives you the perfect square, pull that out, and then you have the number underneath the radical. And certain numbers like 30 or 6, even though they're composite, they can't be broken down any further. They can be broken down, but it's going to be broken out to these prime numbers, or do not have a number that gives you a perfect square, so you can just leave it as is underneath the radical. And of course, you learned how to do a problem, a word problem that's dealing with radicals. Same thing, you just read what they give you, label, see what you find out what you're solving for, and then follow the same procedure as you would do to simplify radicals. Alright, so we've reached the end of this lesson, and I'll see you around.